The broadcast is now starting. All attendees are in listen-only mode.
Hello, everyone. Good morning or good afternoon, depending on where you may be in the world. If you are here for Wi-Fi Performance Monitoring is a Design Tool webinar, you're in the correct place, so welcome. I'd like to introduce myself. My name is Erica Eierman. I work in business development here at 7Signal, so you most likely received an email from me before. So if this is your first time here, welcome. If not, welcome back. And I'd also like to introduce our Director of Global Wi-Fi, Jim Vada, at this time.
Hey, Erica. Hello, everybody. Thanks for joining us today.
Perfect. So Jim, why don't you go ahead and tell us a little bit about yourself and what you do here at 7Signal?
Sure. So thanks. I'm the Director of Global Wi-Fi Solutions here at 7Signal. I am a CWNE and also a CCNP wireless, and I have wireless engineering experience in several different verticals, most recently though in healthcare. And you can follow me on Twitter at Jim Vada, where I sometimes tweet about Wi-Fi, or you can follow my personal blog, framebyframewifi.net, which is entirely devoted to Wi-Fi and other wireless technologies. So if you want a little bit better signal to noise ratio in terms of Wi-Fi content, the blog is where to find me.
Awesome. Thank you, Jim. And before we jump into our presentation led by Jim today, I just wanted to share a little bit more background information on 7Signal, who we are, how we got our start, and what we do today. So we were originally founded in Helsinki, Finland back in 2007 by some Nokia engineers, then relocated our way to the beautiful Cleveland, Ohio in 2012. There was an abundance of wireless knowledge in this area, so 7Signal definitely came and took advantage of that as well. We're also certified in over 40 different countries, and we manage over 4 million wireless devices daily, and that number continues to grow as we continue to take on new customers as well. We have 11 patents, including one that just happened this past April for our newest solution, Mobile Eye. And within the last year or so, we've began the conversion to completely SaaS-based solutions as well. So our tools are continually progressing and becoming more robust to help our customers. So to dive in just a little further on our solutions, we are a 100% cloud-based experience. So we give information from the one enterprise solution and device infrastructure point of view. And we like to say our solutions run off of a proactive framework, so that way we're finding issues and problems before they even occur. So we're doing this by providing our customers with reporting, alerting, and analytic tools that are going to alert them when something within their network or wireless environment is happening before it even happens. So we're doing this through throughput, packet loss, jitter, different tests through your alerting systems to really give you that information before there is large amounts of wireless downtime. I know within healthcare and hospitals, an hour of downtime can cost up to $1 million. So it's really imperative to have these proactive tools to really give you insight into your wireless environment. And looking at this slide within both of our solutions, Sapphire Eye and Mobile Eye, which Jim will dive even deeper into, we work with a large, vast amount of technology ecosystems. So for your intelligence and notifications platforms, we work with Slack and Splunk. So those are just going to give you the visibility and the alerts that you need to stay on top of your wireless environments. We also work with wired and wireless LAN access infrastructure such as Aruba, Cisco, Juniper as well. And we also work among your Internet of Things as well in the bottom right corner. So there's really no platform that 7Signal doesn't work with. And we really pride ourselves on that, to be able to adapt to the systems and tools that you already have, and for you to be able to use 7Signal solutions as well. And before I pass off the microphone to Jim, I just wanted to mention our free regional user groups that we have coming up currently. So if you're attending Wi-Fi Track in the Nashville area on September 17th, we'll be having one of our free regional user groups where you can sign up online or contact me. There'll be an abundance of wireless knowledge. Some of our current customers will be there as well, to just give a testament to how 7Signal really helps them within their wireless environments. Also in October, on the 7th in Prague, we'll also be at Wireless LAN Pros, and we'll also be having a free user group there as well. So if this is interesting to you, you can sign up by using the link below, or you can contact myself or Don Cook, and we'll also get you registered for one of those user groups as well. And with that, I will hand over the controls to Jim.
Thanks, Erica. Yeah, I'm really looking forward to Wi-Fi Track in Nashville. This will be my first time going, and we have a lot of people signed up for our regional users group there, so should be a good week of Wi-Fi.
Yep, definitely.
So let's talk a little bit about what makes 7Signal different and how we can apply some of our tools to the Wi-Fi design process. So first of all, the normal approach to Wi-Fi performance monitoring is this inside-out approach where you're using telemetry from the infrastructure to learn something about its own performance and the client experience. And it has some limitations. For one, we're not really getting all the way out to the client because we've got these APs in the way. And I say they're in the way because often if those APs are experiencing bugs, or there's something wrong with the hardware, or there's a misconfiguration, you won't have any data from clients at all, or the data you have may be skewed in some way. So we really need a method that keeps an eye on those APs as well. And that's what's different about what we do. We kind of sit outside the network with mobilized software agents on your laptops and mobile devices, and sensors, Sapphire Eye sensors that act as clients as well. Really validate that the APs are behaving the way they're supposed to, and end-to-end connectivity works, authentication works, all those important parts of the network are working with a sort of a neutral third-party view of it. It's hard to really get good information from a device that's misbehaving from that device itself, and we help validate that everything's working the way it should. So the two products that we have, I mentioned really quickly, are Mobileye. That's our completely software-based product. It runs on Windows, Mac OS, Android, and iOS, and it's collecting Wi-Fi statistics from clients themselves and uploading that to the cloud, where administrators can see that data and do some analysis on it. And then Sapphire Eye, which is a hardware-based sensor. So you would mount that to the ceiling like an AP, and it would connect to the surrounding APs, run a very thorough set of tests. It also has a spectrum analyzer and the ability to do remote packet capture, which really make it an extension of the wireless network engineer's tool set available remotely, which is a really, really great capability to have. So but today's topic, Wi-Fi performance monitoring systems as a design tool. So it's a little bit different take on what these systems are usually used for. So I wanted to kind of float some ideas out there for people that do a lot of design, and you know, it's a very labor-intensive, time-intensive process, and I wanted to think about some ways that what we do could augment that. So I think of wireless performance monitoring systems in 3 different classes. They're hardware sensors, Sapphire is one, software agents, Mobileye, and then network as a sensor. And those are the other systems that are using telemetry from the infrastructure itself to make some claims about Wi-Fi performance monitoring. So little disclaimer, you always want to, I'm not here to say that we're a replacement for site surveys or that everything you learned in the CWDP book was you don't have to do anymore. That's not the case. You still want to do site surveys. You still want to, do that layer 1 RF design. That's the most important thing in Wi-Fi performance, getting that right from the get-go. And then what we do is come in and help with operations after the fact and troubleshooting. But what can we do to help out that design process? Well, if we look at some of the different phases of wireless network design, one of the first things, and if you've got experience here, it seems simple enough, is gathering requirements, but it actually can be one of the most painful and challenging steps. So you've got clients that often, or I should say customers, that don't really know much about the client population that the network needs to support. They might know a couple of the apps in use, but they certainly know very little about the adapters that are installed on those clients and what their capabilities are. And then if it's a greenfield location, you want to know what the RF environment looks like now. And a spectrum analyzer can help out as well. And we'll look at some other things in requirements gathering as well. But in terms of learning about the client population, Mobileye actually has some really great features here where once it's installed, you can get a simple inventory of all the clients installed, all the clients out there, so you know exactly, right? There's 298 of this model Lenovo laptop. But it goes deeper than that because it's an agent on those machines, right? So now we know exactly which adapters these machines have, and even more than that, we know which driver versions they're running, which is really, really handy because I've got highlighted here, here's an Intel 8260 with very old drivers on it for this particular adapter. And I know firsthand that those early driver versions for the 8260 were buggy and caused a lot of stickiness and roaming issues. And if this was a customer of mine who had, in this case, 66 devices with those old drivers, I'd want to call that out because, they're counting on me, the wireless engineer, to get the Wi-Fi network either to be better than what it is today or install a new one that works really well. And with these old machines, no matter what I would do on the infrastructure side, they're still going to have issues. So I can at least call this out in my final deliverable, say, hey, you got to update these drivers. This is why Wi-Fi performance is poor for some of these, some of your folks, and then, or have it remediated, during the design, and just say, hey, you need to get these updated as part of this process. In a greenfield, and this can be helpful in brownfield too, but in a greenfield deployment, Sapphire Eye has that spectrum analyzer, and it's saving that data to the cloud. So we keep 30 days, excuse me, of spectrum analysis data in the cloud. And so at a new site, before you even show up to do a walkthrough or a site survey, you can have somebody plug in a Sapphire Eye. It's plug and play, just get it internet connectivity and off it goes. And that spectrum analyzer will run 24/7 and give you insight into the existing incumbents, we'll say, in the spectrum. So you might turn up things like this, which was a big, horrible blob of interference. This is not Wi-Fi, this is something else that showed up at this particular site in the 2.4 gigahertz band for a period of about 3 hours, 2.5 hours roughly. So for 2.5 hours, the 2.4 gigahertz band here was nearly unusable, but it was transient. So this thing was here one day, and then it was gone, at least in the hours immediately afterwards. This might not show up during a walkthrough with a spectrum analyzer, but with long-term spectral analysis from a Sapphire Eye, you would see it. And of course, if the customer has any need or requirement for performance in the 2.4 gigahertz band, you need to call this out, because if this comes back, again, it doesn't matter how well the network's designed, this is going to ruin Wi-Fi performance in the 2.4 gigahertz band. There's a lot around capacity planning that our tools can help out with, and I could do a whole webinar just on that, but I'll try to keep it brief and just talk about a few things just to kind of get the ideas, get the wheels turning. But obviously, capacity planning is it can be a pretty complex task, and a lot of it involves calculating airtime utilization estimates, and we use a lot of assumptions when we make those calculations. And what we can do is replace some of those assumptions with real data. So we talk, it's often the thought that, for example, we've got a 3x3 AP, and we've got, we're designing to a specific minimum RSSI. So at MCS 8 and 9, we should always be using, the 2 or 3 highest data rates available. And that's, one of the assumptions that goes into capacity planning often. What we find, though, is that when we look at the data rates APs actually use, there's quite a bit of variability. So let me talk you through these two graphs. So we've got graphs of data rates that 2 different APs are using. On the left, well, first of all, they're both 3 spatial stream 802.11 AC APs, and we're just looking at their 5 gigahertz radios. On the left is an AP these are both from the same vendor as well, but on the left is an AP from a previous generation of hardware, and on the right is an AP from the current generation of hardware. And no, I'm not going to tell you which vendor this is, but suffice to say, you can see that the data rate shifting, the aggressiveness in data rate shifting is higher for the previous generation AP. You can see that it's more often using these highest available data rates with 3-stream clients. In this case, the Sapphire Eye was the client it was transmitting to. Yet the new generation of APs is less aggressive. It's more conservative. It's using these lower data rates. It's using 2 spatial streams a lot more often than 3. And, there might be good reasons for that. Using these lower data rates increases robustness. There should be lower retries. You might have better voice over Wi-Fi performance because latency and jitter and all those things that are affected by retries might be a little bit better. But if you were say a university dependent on using these three-stream data rates with your students' MacBook Pros that have that third spatial stream, and your airtime calculations, your capacity planning, factored that in. Said, oh, I've got all these three-stream clients. We're going to be able to take advantage of that and have better airtime efficiency. Well, that may not be the case. And the great thing is with Sapphire Eye, it's easy to test an AP or a group of APs to get some idea into how aggressive they are in data rate shifting. Similarly, we can look at the data rates that clients use. So these are the client transmit data rates for a group of two spatial stream 802.11ac clients, all with the same chipset, the same wireless adapter. And this is a high density design. You'd expect, our normal assumptions are they're going to be skewed towards the right end of the graph again, using the highest available data rates. But we see that's not the case at all. There's a pretty fat tail over to the left. It's pretty, there's some skew towards those highest data rates, but they're using all the available data rates, even some OFDM data rates and some significantly lower data rates. So in the real world, even with a well-designed network, the data rates in use by APs and clients may not meet those assumptions. And we can use this data collected from Sapphire Eye to help tune those assumptions and make sure we're using the right numbers for our calculations. So this can be helpful for predictive designs as well, because obviously the more data you can throw at a predictive model, the more accurate it's going to be. Just like going out and calculating wall attenuation metrics instead of using the defaults built into your site survey software. If you can learn some real capabilities and real performance numbers about your clients and APs, that can help with the capacity planning. It goes into a predictive model as well. And then there's this, unfortunate circumstance of survey-less designs, which I'm telling you right now, you shouldn't do, but I know it does happen. And if you have a design, it's not even really a design, but if you have a deployment that there was no survey with, then certainly sensors and Mobileye can really help out, because you're going to have a pretty large increase in the operations cost and support load associated with that WLAN. So, getting a sensor out there and having it moved around by the people at that site to wherever the problems are occurring can really help that troubleshooting and support problem. Because now you've got your whole tool set available remotely that you can deploy where it's needed. So another phase of the design process, validation, can be really helped through some of our tools. So, portable sensors like Sapphire Eye, you can have left behind or shipped to a site while the validation survey is going on. And if there's some areas that are really kind of borderline in terms of requirements, meeting the requirements of the design, which happens, there's always those areas where you're kind of scratching your head like, is it quite good enough? We're right on the threshold, and I validated it with my Mecha House Sidekick, but will a real client see it the same way? There's always those questionable areas. So put a sensor out there and, validated over time while clients are there actually using the network and you can see that performance is beating expectations or it's not. Additionally, Mobileye is great for this too, since it's software only. It's easy to distribute it widely, remotely, and look at the real clients on the WLAN to make sure that your requirements are being met. Very simple. The simplest thing to look at is your coverage requirement. You probably had a threshold, say minus 65 or minus 67 dBm for a voice over Wi-Fi deployment, or maybe minus 70 for just normal sort of data-oriented coverage network. Well, Mobileye will show you exactly what minimum signal strength clients at those sites are receiving. So you can go and make sure that those requirements are being met, and also if they're not, which AP the client was connected to and it had a problem. Client roaming, also very important to know about the performance of clients, not because it's usually part of the WLAN design process, but just because it affects the Wi-Fi performance so much that if clients are roaming poorly, again, doesn't matter how well the design of the infrastructure went, the overall performance will be poor for those clients, and it's going to get blamed on you since you were, supposed to, quote unquote, fix the Wi-Fi. So having that data to support the conversations about that is really, really critical. Clients can tell you something about co-channel interference as well, since they're scanning the network from their own perspective, and they can show you where other overlapping BSS IDs are. You can check real client throughput and make sure the applications that you need to reach are all available directly from the clients, which is really handy. So this is what it looks like in Mobileye. And we can tell just from a single client, we've got this assessment over time where we can see if the requirements we have in all these areas are being met. So looking at an individual client, I talked about how you can look at the RSSI it's received. And it's not your site survey adapter. This is the real client that's using the network to make sure that your most of the time your coverage requirements are being met. And we can see in this particular case we have a little bit of a coverage problem where the signal strength dropped pretty low, minus 75 dBm or so. You can see the data rate dropped and the MCS index dropped for this client as well. If we see that pretty often, maybe we need to go do some validation and see what's going on with that particular client. We can also distinguish that from roaming problems. So having an agent on the endpoint means we know not only what its minimum signal strength is, which we can see here on the right, but also if there's a nearby AP. And this is the client's perspective on that. So what's the best signal strength of the neighboring APs from where this client is? Well, in this case, the signal strength for this client dropped to minus 90 dBm, which is terrible. And if that was a coverage problem, it'd be very serious. But it's not a coverage problem because we can tell that the client also had a AP at minus 55 dBm nearby. It just failed to roam, and that's something we'd want to call out. If it was a chronic problem with a specific client with the customer. We can look at this for groups of clients as well, and including by location, which is great if you're distributed. And often you'll do a design for one location at a time, and you really just care about that location. So let's just look at, here's our own network, and we're looking at the 5 gigahertz performance in all of our offices in Ohio. We can see, yeah, in Columbus, there have been some problems. What kind of problems were they? Well, this is kind of cool. We've created these problems where we're correlating the data for you. So instead of going through the data this way and looking at it, which I prefer, I like to look at the raw data and make my own determinations, but we can also show it to you where we've made determinations based on the thresholds and requirements that you've set, and sort of package that up as problem events. So we can show you problems for roaming, coverage, congestion, and general RF problems. And all of these are really valuable for the design process. And we can see which sites have the most of those. We can drill into those sites and see, oh my goodness, our Columbus office, this is embarrassing. Our own 7Signal Columbus office has 172 coverage problems for this particular client. Need to get somebody some Wi-Fi knowledge up there to help them out. And we can drill into these problems. So this is what a coverage problem looks like. And it's very simple. Low signal strength below the threshold that we configured and zero stickiness. That means there are no other APs that this client could have roamed to with decent signal strength. Congestion, very simple. Good Wi-Fi data. And by that I mean the signal strength is very good. Data rate's nice and high. So our Wi-Fi performance at layer 2 and layer 1 is great, but our throughput's poor. So what's going on? Is it an internet circuit problem? Is it is the AP uplink limited somehow? Is there rate limiting going on? We don't know, but you know, if your throughput's, if you're only getting a megabit of throughput, you're probably going to have some folks complaining or grumbling about it. And what do they blame first? Well, they blame the Wi-Fi first. But with this kind of data, we can tell, hey, actually, the Wi-Fi performance was excellent at this point in time. Somewhere further upstream, there was a problem. And then RF problems. And these are more general problems. But what we're saying is, you know, your signal strength's very good. We're not seeing any obvious problems, but the data rate is really low. You know, with a signal strength of minus 50 dBm, especially in the 5 gigahertz band, you can see that connectivity here. Why would our data rate be so low, 13 megabits per second? There's probably a source of interference. There are retries building up, lots of collisions perhaps. Something's wrong with the RF. Maybe we have too many APs on the same channel. Maybe we've got neighbors running their own APs in the same spectrum. Maybe somebody turned on a microwave. Maybe, you know, on and on and on. But these are all symptoms of RF problems. So that's where that comes from. Definitely something we'd want to investigate further if we saw that showing up in a site that we design. And so, you know, the last benefit to using our tools in the design process is it makes it really easy to turn it over to operations or to continue using them if you're going to be in charge of operating the wireless LAN yourself going forward. Because that's really what these are designed for in the first place, was for 24/7 operations and troubleshooting and reporting and alarms, so that the people that are in charge of running the network can remediate problems much faster, discover root causes much faster, get really insightful and valuable alarms, and also to simplify remote troubleshooting. And so the tools we have are a great help for that once the design process is complete. Okay, and I think with that, our next slide is the trivia question. Is that right, Erica?
Yeah, thanks so much, Jim, for diving in deep into our solutions and giving us more information on that. I certainly learned a lot. So thank you for that, Jim.
My pleasure.
Oops. Oh, alrighty.
I think I had
So
some
hopefully you
mouse
didn't see.
clicks kind of get delayed there.
I
There we
know,
go.
I know. Hopefully we didn't see our trivia question there too quickly, but you can use the chat portion over on your GoToWebinar panel on the side of your screen to answer this trivia question. First person to get the trivia question correct, I will send you a $25 Panera gift card. So go ahead and use the chat portion over on the GoToWebinar panel, and we will see what answers flow in. So the question is, what is 14 dBm in milliwatts?
It's the kind of thing that pops up during design work, especially when you're comparing APs and clients and you've got a lot of different spec sheets. Sometimes you get numbers in dBm and sometimes you get them in milliwatts, and you need to be able to do some conversions to be able to compare them.
Alrighty, we'll wait another minute or so here for some answers to pile in. Alrighty, so we have a answer here, and it is the correct answer. So the answer for this trivia question was 25 milliwatts. And so our first person to answer that correctly was Renee Reitel. So Renee, I will be sending you your Panera gift card in the mail. Please feel free to reach out to me as well and make sure I have your correct address as well so I can get that to you as soon as possible. And with that being said, we're going to switch it over to our question and answer portion here. So this is the time to ask Jim any questions you might have that might have come up during the presentation. You can use the question panel on the GoToWebinar panel as well. And we'll give everyone a minute or so to let those questions flow in. All righty, looks like we have a question here. So Jim, we have a question for you here. How are we differentiating 7-signal tools from other tools like Wireshark?
Yeah, that's a great question. And Wireshark we work with very well. So Sapphire Eye, that hardware sensor, can serve as a remote packet capture device. So you can run a packet capture at a site, several time zones away, just by having that Sapphire Eye there. It'll use it can do an over-the-air packet capture everything on the channel that you can use, and then you can use Wireshark to do protocol analysis on that if you really want to get in the weeds. So they're very complementary tools in that case. What differentiates us from others too is that we're, again, outside looking in, taking an unbiased neutral view of performance that's not colored by bugs or hardware failures or anything else that's going on in the infrastructure. So you know, that's a big difference for us.
Awesome. Thanks so much for that explanation, Jim. It doesn't look like we have any more questions flowing in. So if you do still have some remaining questions, feel free to reach out to myself or Don Cook, and we can always relay those questions over to Jim Vada as well and get those answered for you. But with that, I wanted to thank you all for being here today. And if you would like to set up a demo to learn more information on our wireless network monitoring solutions, I'd be happy to do that for you as well. Also, look out for a $5 Panera gift card in the mail from me that I will be sending after this webinar as a thank you for attending. And we hope to see you again at some of our future webinars. Thank you, everyone.